our team would like to present about a DFMA case study of an automatic door remote. Uh, my name is Fakhrizadi bin Rashidi, and with me is Kishore Kumar and Yap Kok Dong. The subject is automatic door remote control. Core function, a handles consumer device designed for remote actuation of automatic door. Engineer context, selected for DFMA analysis due to its hidden structure complexity. Contain a multiple assemble made from distinct material, plastic, metal, rubber, and rely entirely on manual disassemble and reassemble utilizing simple tool. Next is constructing the architecture. Housing assemble, uh, control assemble, fastener, control assemble, electronic assemble, key attachment assemble, key inside. The automatic door remote with automatic door to design and and electrical component. Electrical component. Next. Material specification and manufacturing. Upper, lower, cover and rubber pad made by nitride, butanic extract, rubber, process injection molding. Button and buckle made with aluminium. The process is injection molding. Screw made from zinc plate carbon steel, and the process is cold heading, thread rolling, and zinc plating. The ring made from spring steel wire. Process is wire drawing, cutting, forming, heat treatment, and nickel plating. Battery and circuit board made by multi-material, and the process is off the shelf. Supplier and source. Next, baseline assemble efficiency dashboard. Total assemble time is 39.05 seconds. Total assemble cost is RM 15.1519 cents. 15 ringgit 19 cents. Design efficiency is 0.17. Component button. Quality is smooth. Symmetrical angle is 360 and B360. Handling time is 3.45 seconds. Cost is 1 ringgit and 38 seconds. 38 cents. The takeaway is the current architecture requires 39.05 seconds of manual assembly. The dashboard isolates the primary point of handling friction, the dual button configuration. Next. Next.
Friction point of redundant manual holding. The action is inserting two separate small parts and two into the upper cover. For the physics, high summary penalty A360 B360 requires specific orientation and alignment twice. The penalty is each independent insertion sorry the penalty each independent insertion requires grasping and orientation and bracing, resulting compound manual holding of 3.45 seconds and isolated cost of 1 ringgit and 38 cent 1.38. Conclusion: twin distant motion of unapplied user action pressing button is structurally inferented. Okay, and next up. Okay, engineering the solution component ingredient interrogation. The redesign of strategy merging two separate buttons into one single component in contrast and integrate button component. CAD executive design is SolidWorks to accept housing tolerance, maintain or original user-friendly while eliminating internal separation. Manufacturing intent, single mode injection molding, reducing tool wear and part tracking complexity. Next is uh, the action we are taking. One fluid integration of a single component. The physics improve orientation synchronity A360 B90, simplified orientation, and the benefits are handling time plummet from 3.45 seconds to 30 seconds. Manufacturing handling cost drops from 1.38 to 1.2. The conclusion is redesign simplifies the assembly process of the floor without uh, sacrificing end user functionality. Next, yep. Okay. The next is the delta matrix quantity theory design. If we follow the original old design, the original dual button design, we need two parts, and handling since symmetry is 360. Manual holding time is 3.5 seconds, and component cost is 1.38 seconds. And the new integrated button only requires one component, handling synchrometry 360 and 90. Holding manual holding time is only 3 seconds, and the component cost is 1.2. Next, optimize assembly efficient dashboard, where the new total assembly time is 38.60 seconds, and total assembly cost is Rm 15 ringgit and 72 cents, and design efficiency is 0.70, where the button integrated button only has one quantity, A360 B90, handling time 30 seconds, and cost is 1.2. By executing a targeted redesign of a simple friction button, the entire assembly is sequence is shortened and generated value measurable drops in total time and total cost. Okay. Next, yep,
Scaling the impact A 1, 2, 3, 4, 5, 10,000
100,000.
100,000 unit production run. The time multiplier saving multiplier saving 0.45 second per unit at 100,000 unit is 4
45,000.
45 second save. In fact, 12.4 solid hours of, of manual assembly labor eliminate per production cycle. The cost multiplier saving 0.80 per unit at 100,000 unit is 80,000 80 100 80,000 safe impact direct bottom line saving task reduce handling and part searching costs. The design efficiency product theory vs reality. The formula turn total design efficiency remain math- mathematically static at 0.7 for both design due to the overriding constant of the 9 total base part in the calculation. The particular the practical reality manual operation is demonstrably reduced installation time physically drop, assembly cost is lower. The engineering inside DFMA is not just about chasing a theoretical efficiency score. True engineering mastery, this is recognizing that reducing component complexity even when hidden by broad formula unques- unquestionably optimize physical manufacturing and assembly reality. Project studies and team reflection. Technical mastery, dependent understanding of how material selection and component structure directly dictate manufacturing process and downstream DFMA performance. Two profession to proficiency translate extra improvement plan into industry standard reality. Thus, SolidWorks CAD modeling generating manufacturing ready engineering drawing. Cor- collaborate collaborate execution PO5. The redesign was a product of active test coordination, overcoming design challenge required price, technical communication, share responsibility, and a unified, unified approach to engineering problem solving. Thank you.
Okay, thank you. Yeah. Now for the conclusion, this project successfully applied the DMFA methodology to analyze and improve the automatic door remote control. Through this product assembly, the team determined the product's structure tree, materials, and manufacturing process, and the assembly sequence of each component. Thank you.